This is Algebra 2, Chapter 5, Unit 3. Now we're going to look at zeros. Zeros are the points at which the function intersects at the x-axis. A polynomial function with a degree of n can have at the most n real zeros. An even degree polynomial has an even number of zeros or no zeros. An odd degree polynomial has an odd number of zeros. So let's look at some examples. Let's identify the zeros by graphing. So we're going to graph each function and identify its zeros. So you'll see over here on the right side we have the function of x cubed plus x squared minus 2x and the graph for that. You can either graph this by using your graphing calculator, or you can use a t-chart to input the x's and get your output. Our graph should look like this. And now we want to identify the zeros. So remember that the zeros are the points at which the function or the line intersects the x-axis. So it intersects right here, and right here. So, and the first point it intersects is at -2, where x equals -2 and 0. The second point is at the origin, or 0, 0. And the last point is at where +1 and 0. So a thing to remember is your y, when you're looking for zeros, your y is always going to be 0, okay? And your x value is going to have a value. So our solution set is -2, 0, and 1, or our x values at which the function crosses the x-axis. Now try number 2 on your own. Go ahead and pause the video while you do that. Here is the solution for number 2. It is -1, 1, and 3. And here is the graph, what your graph should look like. Notice that it crosses at -1, +1, and 3. Now let's look at linear factors. The linear factors of a polynomial reveal its zeros. Linear factors can be found by writing the polynomial in factored form. So some examples we have is write the function of x equals x cubed minus 2x squared minus 15x in factored form. Well, in factored form, we want to look for any greatest common factors that all three of those terms have in common. In this case, they all have an x value. So we're going to go ahead and take out an x. Now we're left with x squared minus 2x minus 15. Well, that's not complete because we can still reduce or factor this. So when we factor that, we are left with, we're looking for products, greatest common factors of 15 that when added together equal -2. In this case, that would be a -5 and a +3. When -5 plus 3 would equal -2, and -5 times 3 equals -15. Now you go ahead and set each term equal to 0. So you set this x right here equal to 0, x minus 5 equal to 0, and x plus 3 equal to 0, and solve for x. So the zeros are going to be x equals 0 because, well, x equals 0 right here. Then you have x minus 5 equals 0. You go ahead and add the 5 to both sides, and you get a +5. And x plus 3 equals 0. You subtract 3 from both sides, and then you get a -3. Okay, I apologize. That should be a negative right here. Okay, so your answer would be 0, 5, and -3. Multiplicity. The multiplicity of a zero is equal to the number of times its corresponding linear factor occurs. So we want to write function of x equals x cubed minus 6x squared plus 9x in standard form and then identify the zeros. So we can go ahead and factor out an x from all three terms. So we factor out an x. Once we do that, we're left with x squared minus 6x plus 9. So we're looking at this 9 to see what factors of 9 that when added together equals -6, but when multiplied together equals +9. Kind of like a riddle. So we know that -3 and negative 3, when added together, would equal negative 6. And negative 3 times negative 3, well, a negative times a negative equals a positive, and 3 times 3 equals 9. So our answer is x times x minus 3 times x minus 3. Now we would set each one of these equal to 0. Or you can write it like this. We have x and x minus 3 equal squared. So now we want to identify their zeros and their multiplicity. Well, when x equals 0, that only happens once. We have one exponent right here, so the multiplicity would equal 1. Now, when x is minus 3, and you set that equal to 0, well, x minus 3 equals 0, x equals 3, so your x would equal 3, and the multiplicity would equal 2 because you're doing that 2 times. You have a little 2 exponent of 2 right here, so the multiplicity is 2. Now, we want to look at how the multiplicity affects a graph. So we want a graph function of x equals x cubed minus 6x squared plus 9x. You can either graph it by using a t-chart or using your graphing calculator. So here's what that graph would look like. If the multiplicity is odd, then the graph crosses at that 0. If the multiplicity is even, then the graph bounces at that 0. So notice that it crosses at 0, okay? So let's watch a video more on how multiplicity affects a graph.
In this lesson, I'm going to teach you about how the multiplicity of a zero affects the graph of its function. So let's look at the first sentence that I have here. It says the graph of a function is affected depending on whether the multiplicity of a zero is odd or even. So I have 3 different scenarios here that I want to describe to you. Let's start with the first one here. It says case 1, the multiplicity of a zero is positive 1. Now, if a multiplicity of a zero is 1, then the graph of the function crosses through the x-axis at that particular zero. So to look at this type of behavior, let's make a function y equals where its zeros have a multiplicity of 1. So you can always start with a factor x plus 1. Okay, so and since the zero is going to have a multiplicity of 1, the exponent on this factor is going to be positive 1. So we're actually going to graph a linear function here, y is equal to x plus 1, where the 0, or the x-intercept, is going to be at negative 1. So let's take a look at what happens on the graph here when I graph this function. So go to your y equals screen, plug in x plus 1. Try a Zoom 6 standard for now, see if that works, and it's perfect. And notice what happens at the x-axis at its 0. It crosses the 0 once at the x-axis. So if I was to draw my graph on my lesson here, here's my 0, negative 1, it's going to cross that 0 once, and that's what happens when your multiplicity of a 0 is exactly 1. Let's move on to the second case here, where the multiplicity of a 0 is odd, but it's greater than 1. So if this happens, the graph of the function is tangent to and crosses the x-axis at the 0. So once again, to describe this behavior, let's write out a function with this type of property here. So we could start with x plus 1 again as our factor. Since our 0 has to have a multiplicity of an odd number that is greater than 1, let's pick an odd number greater than 1, and that would be, let's pick 3. Okay, so we're going to graph this function here. Remember, the 0 doesn't change. X is equal to negative 1 is still the 0. So let's take a look at what happens at that point. So go into your calculator, clear whatever you had in there before, and you're going to plug in x plus 1 cubed. And let's see what happens at the x-intercept. We get a graph that looks like that. So yeah, once again, we still have a 0 of negative 1, but this time the behavior is different. It's tangent to, but it also crosses at that point. So if I was to draw this a little bigger on my lesson here, here's the 0. My graph is tangent to, so it just touches it, but then it also crosses it in the end, just like that. That's what it looks like when your 0 has a multiplicity of an odd number greater than 1. Okay, so moving on to my last case. The last case is where the multiplicity of a 0 is an even number. And when this happens, the graph is tangent to the x-axis, but it also does not cross it. So tangent to does not cross it. Let's pick another polynomial here to graph. Y is equal to, let's pick the same factor, x plus 1. This time the multiplicity has to be an even number. So let's pick 2, which is an even number. We still have the same 0, x is equal to -1. Obviously, the behavior of the graph at that point is going to be a little different than my last two examples. So go into your calculator, clear whatever you had in there. We still are using x plus 1 as our factor, but our exponent, our multiplicity in this case, is going to be a little different. It's going to be even, and we have chosen 2 as our multiplicity. So if we graph it, we have a quadratic graph, which is also known as a parabola. And that parabola, look what happens at its x-intercept, or its 0. At that point, it's tangent to the x-axis, but it does not cross it. So if I was to sketch this graph on the side here, here is my 0. The graph is a parabola that is tangent to the x-axis at that point, but it doesn't cross it. So please be aware of what the differences are between each of my multiplicities here, and that will actually help you sketch any type of graph there, knowing these 3 characteristics. So that is how you use the multiplicity to predict what happens at your x-intercepts.
So next we have the function of x equals x plus 7 squared 2x plus 1, x minus 4 cubed. We want to look at our zeros, multiplicity, and effect. We have -7 for our 0, which would be right here. Our multiplicity would be this 2, so 2. And we know that it's even, so it's going to bounce. Now we have a 0 of -1/2, so 1 divided by 2 would be -1/2. A multiplicity of 1 because there's no exponent, and we know that since it's odd, it crosses. Now we have a 0 of 4, +4, a multiplicity of 3 because that's how many times it occurs, and it would cross. Same for here is what number 7 function would look like. You can go ahead and pause the view while you write that down. Next, we have number 8. A polynomial function has a 0 at -6, multiplicity of 2, and 2, multiplicity of 1. Write a polynomial function in standard form that could represent this function. Well, we're first looking for that 0 at -6. So we know that since our x is going to equal -6, when it's inside our function, it's going to be a +6. And so our multiplicity is going to be 2 because it occurs 2 times. Now we have a 2, a +2, and a multiplicity of 1. So when it's inside the function, since it's +2 for our 0, it's going to set x equals -2 and equals function of x. Then you can go ahead and you square this x plus 6 squared. Go ahead and solve for that. And then you go ahead and multiply them together. Go ahead and solve the function and combine like terms, and that would be your answer. That is it for chapter 5, unit 3. Go ahead and rewind the video or push pause for any additional notes. Thank you.